Okay, this video is about finding arcs given central angles, but in order to do this, we first need to make sure that we understand some different things about circles. First thing that we got to understand is, what is a circle? Well, by definition, a circle is a set of points that are equidistant from a given point that is called the center. Also, all circles have a measure of 360 degrees. That fact is going to become very important for some of the things we're going to be doing in this video and in future videos. All right. What is a diameter? We should know that a diameter is a segment that goes through the center of the circle and its endpoints are on the circle. All right. So a diameter goes through the circle with the endpoints on, and a radius goes from the center of a circle to the circle itself. All right. And then when we talk about measures, we know from the past that the radius is half of the diameter. All right. So real quick on these, I just want to make sure that we're all good. As we said, if it's a circle, all circles have to have a center. When we're talking about a diameter goes from one side of the circle through the center to the other side of the circle. All right. We're also going to learn another name for this diameter is called a chord, but that's down the road for us. All right. Once we have a diameter, if I only look at half of it, so from the center to the circle itself, that's known as our radius. All right. And as we said there, we know that the radius is half the diameter, or the diameter divided by 2. Now, we're going to introduce something new today that is called a central angle. Now, what a central angle is, very simply, is it is an angle whose vertex is at the center of the circle. In other words, it's an angle, which means it has to have two different edges to it, just like this. And this angle in here, we're going to call this angle O. All right, this angle in here is what we call a central angle. Now notice that the two sides of the angle are both radii. Think of the angle and specifically the vertex as kind of like a mouth. All right. From this central angle, I know I'm going to be able to bite off part of the circle over here. We're going to be talking about that down the road. So if I give these a couple more letters, I know that this central angle would be angle AOB. Now, the symbols that we use for these things are going to be very, very important in this next unit. All right? AOB with the angle symbol has a different meaning than AOB with another symbol. So the symbols are critical here. All right. Now, we're going to talk about this thing that is called an arc of a circle. And very simply, it's a part of a circle, but on its rim. All right? Let's look at that right away. So we just learned about this thing, that if I have a vertex in the center, and I have some angle that gets created here, and again, we'll call this AOB, I have an arc of a circle, which is this piece right here that I highlighted. That would be the arc of that angle. Okay? Very, very, very important. We're going to see in a little bit. Now, there are 3 specific kinds of arcs that we refer to in a circle. The first one is called a semicircle. And a semicircle, very simply, is the 2 arcs that get created. The 2 arcs that get created by a diameter. So if you notice, AB is a diameter. It goes through the center of the circle. All right. I know that if I go across the top here and I go across the bottom here, I've created 2 semicircles from that circle. Now, one thing that's going to be really, really important for us is any time that I'm going to be talking about something that is specifically greater than 180 degrees, or better yet, 180 degrees or greater, I want to use extra letters to kind of help describe the path that I'm going to take. For example, if I were just talking about the semicircle across the top here, if you notice, I threw another letter in there, and that allows me to name this as arc ACB. It starts at A, it goes through C, and it ends at B. And then I'm going to use this symbol called an arc symbol over the top. All right, with that being said, if I come back to this previous one right here, I know that this arc is really arc AB. I only needed 2 letters there because it was clear, and this is also going to be known as a minor arc. A minor arc, when you only use 2 letters, can only be described for angles or arcs that are less than 180 degrees. All right? So if I wanted to talk about the arc that goes from A to B here, if I look at that pathway, I know it's less than half of a circle. And if it's less than half of the circle, that being the center, if it's less than half the circle, I can call that a minor arc, and I only need 2 letters to describe it. I could call this arc BA, or I could call this arc AB. Both are saying the same thing. Now, if we have an arc that is greater than 180 and less than 360, remember 360 is 1 trip around the circle, we call that a major arc. So a major arc has to be bigger than a semicircle, but smaller than the whole circle. So for instance, I'm just going to throw some points here. Let's say that I have points A, B, and C. All right? And let's say, just to kind of mess with you a little bit here, let's say I want you to name that arc. Now, a lot of guys would just say, well, I'm going to just say ABC with the arc symbol over the top. And that would be wrong. Because remember, when we name a major arc, we want to name a point that it starts at first, a point that it passes through second, and a point that it ends third. So for example, for this major arc, I could call this arc ACB. Or I could call this arc BCA. And if you notice, anytime that I'm naming these arcs, I'm always staying on the rim. That's what it means to be an arc of a circle. So what's our focus? Now that we've got some background, this is our focus for today. All right, this statement right here is all that we need to learn and be able to apply from today's lesson. And it says that the measure of a central angle is equal to its intercepted arc. What is that saying? Well, first I look at this first picture. I see that this angle right here has a vertex at the center. If that angle is 65, then remember its mouth or its intercepted arc is going to be right there. If the angle is 65, then the arc is 65 degrees. Pretty simple concept. But what they're going to do is they're going to try to mess with us a little bit and give us a little bit more, sometimes too much information. Sometimes we got to think about the information that they gave us. For example, they want me to find the measure of arc RST. Now, arc RST goes like this. That's the arc. Right now, I know of no measurements on the arc itself, but I do see 2 central angles. I know that if this central angle is 125, this arc is 125. I know that if this central angle is 80, then this arc is 80. And to be able to find the measure of arc RST, I'm going to add the arcs together. 125 plus 80, which would tell me that the measure of arc RST would be equal to 205 degrees. Okay? How about this scenario? They want me to name or find the measure of arc I, so I'm going to start at I, G, H. Now, there's a couple of different ways that you can go about doing this. One way would be to find this arc measure, which we could do. That's a semicircle. It's 180 degrees. This arc measure, and add those two arc measures together. But think about the big picture as well. All right? We've got to really, guys, when dealing with circles, keep our mind open to what we see and what we know. Well, here's one thing that I know. If I start at I and go all the way around the circle and end up back at I, that's 360 degrees. One trip around the circle is 360. Well, based on that and this idea of a central angle, I know that if that angle is 59, then that arc is 59. So what I'm able to deduce here is that the measure of arc IGH is all the way around the circle, but I got to take off a part that's not included. So I'm going to subtract 59. And that tells me the measure of arc IGH is 301 degrees. All right? So I've got to be able to think about everything involving a circle. Now, we're going to focus on this idea that a central angle is equal to its arc, and now bring in some algebra as well. So let's take a look at this first problem. How would you approach this problem? There's a couple of different ways. I'm going to keep a fairly fail-safe way of doing this. And that is that if I know these are central angles, which all three of them are, then I know that the central angle is equal to its arc. I know that the three arcs have to add up to 360 degrees, one trip around the circle. So I'm going to add 3 plus 21x plus 95 plus 115, and I know that these three arcs have to add up to 360 degrees. Grab my handy dandy calculator here. I'm going to combine like terms. So I've got 3 plus 95 plus 115. That gives me 21x plus, I think that was 213. Yeah, plus 213 equals 360. Subtract 213, so 21x is equal to 147. And if I take 147 divided by 21, I get 7. All right? Take a look at this next one. The only difference here is we don't know the actual measurement of two of the central angles, but that's okay. We know that central angles are equal to their intercepted arcs. So I'm just going to mark each of these arcs as their corresponding measures. I'm going to add the three arcs. I've got 22x plus 7 plus 95 plus negative 2 plus 30x is equal to 360. One arc, second arc, and here is a third arc. Combine like terms, I get 52x. And then let's see, I've got 7 plus 95 minus 2. So that would be 100 is equal to 360. Subtract 100, 52x is equal to 260. Divide by 52, and let's just check it. 260 divided by 52 would be 5. All right, And the last kind of problem I want you guys to do here. All right. What if they give me a bunch of numbers, a bunch of arc and angle measurements, and they ask me to find a particular arc measurement? Well, what that means is I'm going to have to set up an equation to find x first. Sorry, needed a drink there. All right, so what I know here is each of these central angles is equal to their intercepted arc. All right, which also means that if I add up all of these angles and arc, if I add them all up, that would allow me to find x. So let's see, if I take 14x plus 3x, that would be 17x. And then I've got, let me grab my calculator here. I've got 63 minus 7 plus 121 plus 9 plus 55 equals 241. And again, all I did there was I took out that first step that I had been doing, guys, and combined my like terms right away. I know that those two have to add up to 360. So 17x, subtract 241. Let's see, that would be 119. 119 divided by 17 would tell me that x is 7. Now, if x is 7, remember what they wanted me to find. Arc ij. So I know that the measure of arc ij, which is a minor arc, is 3 times 7 plus 9, or 21 plus 9. 21 plus 9 would be 30. So the measure of arc ij is 30 degrees. Let's try one more like this, guys, just so you've seen plenty of examples of these. All right, let's take a look at this one and think here. Now, I know I got to find the measure of arc IE, which means 18x plus 7 is my equation that goes with that arc. I know I need to find x. But in this particular scenario, we only know central angles for 2 of the angles in the circle. That's all right. I recognize that Fi is a diameter, and a diameter cuts a circle in half. So here's what I know. If I take 18x plus 6x, that would be 24x, and then add 5 and 7, so plus 12, I know that those 2 angles have to add up to 180. Why? Because a semicircle is 180. So 24x is equal to 168. And if I take 168 divided by 24, I get x is 7. I can then say that the measure of arc IE is equal to 18 times 7 plus 7, or the measure of arc IE, let's use the calculator, 18 times 7 plus 7 would be 133 degrees. All right, make sure that you guys are taking notes on this. This is going to be real important for something I got planned for next week. Good luck, and let me know if you have any questions.